So let me try to introduce this in a slightly different way than I normally do. So, like we just discovered, there is a true... Oh, sorry, Chris. Were you sitting there?
Yeah.
Or were you over there?
Okay.
Whee! Earthquake! Oh. And then an earthquake happens, and you guys say, you did your stats magic to me now. Okay. If I told you that I feel like the average age of students at Grossmont is like 45. On the face of that, what do you think? I'd say probably not. Now, what are you basing that on?
People we see every day.
The people you see every day. So it's basically the sample you've taken already. You've already taken samples of the population, so you can kind of already gauge. You can test my claim individually. Now, might there be somebody who might think my claim is correct? Yeah, there could be courses and times where most of the students taking it are older. Does it make sense? So their own personal sample is sort of not random. It's kind of biased. Everybody's sample is biased in some way, but those would be extra biased, right? Okay, so my point is this. How would you show me that I'm wrong? And you can't just say, well, I've seen people. No, you got to show me. How, if I felt, my claim was the average age of Grossmont students is, 45. How would you go about showing me I'm wrong? And you're not allowed to go to, like, our own statisticians and say, can you just tell us this fool over here what the age is? You have to go do your own data collection. Take a sample, I like it, and calculate something. The mean age, I like it. Now, even then, if you get an average of 27, I'm like, well, I didn't prove shit. I could still be right. Yeah, because you just took a sample, right? You guys, I really want you to, combining everything we've done so far. Basically, what we're about to get into is something that's got several steps to it that basically takes in almost everything we've done so far. You really have to understand it.
So multiple samples.
All right, you can take multiple samples. That makes it a little bit better. Because then if I keep repeating the results that I get, and then I can actually combine all my data again, make one big sample, larger N, which would be even more evidence. But what are you trying to show me? I still haven't heard something, obviously, to show distance between. That's what you want to show me, that my guess, my claim, is far away from your results. And of course, that requires standard deviation, so I can calculate a Z-score. Now, do either of us actually know what the average age of Grossmont students is? So what the shit am I going to put here?
The mean of your sample.
No, that goes there. So what you're doing, and let's see if this makes sense. Let's see if you guys have heard this. Have you ever heard the phrase, all right, assuming you're right? Have you heard that phrase? All right, let's say you're right. Let's say you're right. Look at this. You know, I always clean it over the kitchen end. Let's say you're right. Look at the kitchen. It's dirty. So I assuming you're right, and then I show evidence that you're wrong. So when we do what's called hypothesis testing. Oh, that sounds painful, Jeff. Oh, it's bad. I assume that the claim being made is correct. That doesn't mean that I stop. Oh, let's say you're right. Okay, you're right. Let's go home. No, let's say you're right. Let's see what that leads to. So if you say, let's say you're right, Jeff. Let's say it is 45. But I took a sample of Grossmont students. I took a sample of 87 Grossmont students. Go with me now. What was my claim? I claimed that the mean was 45, right? I'll say, okay, assuming you're right, Jeff, I'll meet you tomorrow. You go out and you take a nice random sample. You make sure you represent all of Grossmont students and all that kind of shit. Make a nice random sample. 87 students. And you get a sample mean of what?
24.2.
What's that again?
24.2.
24.2. And it's really fast. He just did that. It's crazy. Ran out here. And let's say a standard deviation of 3. let's say 6.
Okay.
Just to double your thing, just random. All right. Now, what would you do from there? So I'm assuming you're going to assume that I'm right, that is the mean. So then you can calculate a z-score. This is slightly better than confidence intervals trying to check a claim, because confidence intervals base their stuff off the sample, and that's an unknown thing. This says, let's assume that this is the middle of this normal distribution. Let's say that the 45 is. Well, then what we just did would be remarkably unlikely. So let's finish this out. What would the z-score be in this case? Well, first off, what do I have to do? Now, this is where people really freak out. A lot of people don't think they have to do this because I have S, but that's silly. This is the standard deviation of what? Individuals. I still have to change it to be the standard deviation for groups of 87. Don't go, it's already a sample. Say, no, that's not the point at all about that whole divide by the square root of n thing. That is, it's individuals. It's calculated from individuals. I need to transform it into the one that works for groups, right? So I don't care if it's sigma or S that you got. It ain't the right thing. So you got to do S x bar is 6 divided by the square root of 87. Whatever the hell that is. It's like 0.6.
0.64.
Ah. 0.64.
3.
I like that. And then 3. All right. So now I can do my z-score here, right? Now, everything we're doing right here is old news, right? Right here is old news. Old shit. I like it. My z-score would then be 24.2 minus what we're assuming to be the mean,
45.
divided by the new standard deviation. Divided by 6. Divided by 13. 40. Is it 40?
Oh.
Did I do it too? What is it? I was not too far. Negative 32, who cares, right? Negative 30 frickin' 2. So I really want this understood here. So there's a claim that's being made about a population. I thought the average age was 45. You went, oh, holy shit. Let me go take a sample and get the standard deviation from that. Use it to estimate it. I got to change. Oh shit! But I got a z-score of negative 32, assuming that is the real middle. So what I'm doing is I'm given a claim to work with. The mean is 45. So I'm saying, okay, let's assume that you're right. Let's assume that the mean is 45. I went and I got a sample of, where'd you go? 24.2. Which it turns out, if that is the real mean, I just went and did something that is unbelievably unlikely to do. I mean, this is basically a probability of 0. Maybe it's 0.00 80,000 zeros and then 2 or something, right? That's basically no chance. Are you guys? I really want this understood. So assuming I'm right, look what I just did. Right? Assuming that I'm right, you just did something that, if I'm right, would be remarkably, almost impossible. So therefore, what's more likely? I'm right? Or is it more likely that the mean is lower? Mean is lower. Right? It's more likely the mean is lower. There is a chance that I'm right. Like I said, maybe 0.087 more zeros, and then there's that chance that I'm right. So what's more likely is I'm wrong. The actual mean is lower. Is the actual mean 24.2? No. I don't know what the real mean is, but this sample mean is evidence that it's lower than freaking 45. Shit, yeah. And now again, we're just getting into this idea, but I've never kind of said it that way until later, and I think people don't really get the point. We treat this as if it's the real mean, and we try to find a contradiction. Okay, suppose you're right. Look what I just did. That can't be right then. Yes, ma'am.
So then where'd you get the 24 point
And that would be from a sample that I took. I said, let's take an imaginary sample of 87 gross month students.
Like the actual mean.
That was the sample mean of the 87.
Okay.
Sample, yeah. Again, nobody has a clue what the actual population mean is. But if I take a sample of 87, it should be evidence. It should be able to be used as evidence. So this is that whole within a reasonable doubt thing, right? This would not be a reasonable doubt. Holy shit, this is like, no, this is insane. You're crazy. So again, it's that whole, now we're coming to, well, negative 32 is obvious. But what if I got negative 1.98? Is that far enough away to say that? Well, it depends. Before it used to be 2 for sure, but now it's going to vary based on, sometimes it's going to be based on how bad it would be to make a mistake. So let's say that I claim that everything's fine in the nuclear reactor. I probably want to get off my ass the minute that it's possibly not fine, right? So I don't want to make unusual to start at 2 and negative 2. I probably want to make it start like as the needle starts to think about approaching yellow, I'm off my ass, right? You guys understand? Even though Homer Simpson did it fine for way too many years possibly. But all right. All right, maybe. Now, let's get into some details, because this is just idea behind this. This is why we take the claim and we treat it as the mean. Because that's the setup. Assuming you're right. Let's see, well, oh shit, look what we just did. We just did something that's basically impossible if you're right. So guess what? You're wrong. Or me, in this case. I'm wrong. Okay. So, let's break this down a little bit and get some more specifics. There's going to be 5 steps to this hypothesis test. And the book has its own little worksheet in the back it refers to you to. Screw that thing. We're going to answer the same questions in a better order if you do my thing, right? Yeah, Jeff, it's not even my thing. It's modified for my teacher. He had 8 steps we had to go through. I've gotten it to 5 steps that I like. All right. So the very first thing is a claim has to be made. Now, when a claim is made, so let's just kind of use this for example, like mean is 45. There's 2 possibilities for it. It could either be what's called a null hypothesis, which is given the moniker HO, which I'll affectionately refer to as the hope, or the alternate hypothesis, which in this book is given H1, which looks like high. So we got the hose and the highs. Another book I used had hose and the ha's, HA for alternate, which made more sense, but all right, everybody with me? Anybody offended about anything? Too bad if you are. I always like to say if you're offended, just wait a minute, I'll probably offend you again. The null hypothesis is kind of like the stick in the mud thing. The alternate one is the one that I can show evidence for. So let me ask you this. Can you ever prove that the mean equals a number by taking a sample? What did we do in this case? We showed evidence that the mean did not equal 45, didn't we? In fact, we kind of showed evidence that it's less than, but I showed evidence that it's not equal to 45. So you can find evidence that the mean doesn't equal something. But if I take a sample, is its mean going to equal the real mean? No, I could never show evidence that the mean is something. So the alternate one is the one that I can show evidence for. So it can never have an equal sign in it. You cannot show evidence that the mean equals something. I really want this understood. If you wanted to prove to me that the mean age actually was 24.2, could you do it with a sample? You find a sample, hey, I got 24.2. I'm like, I don't care. It's a stupid sample. I don't care. What'd you have to do? You'd have to actually go take the whole population and the whole thing goes to shit. I mean, what's the point of that? Do you guys understand? This is crucial. I can never prove using a sample that the mean or a percentage, because we're going to get those two, equals something. I can show evidence that it's different from something. Just like this. I think it's 45. We got a sample that was so far below it, 32 freaking steps below it, that I showed evidence that it's not 45. But how close do you have to be to show evidence that it is 45? I don't care if you get a sample that's exactly 45. That's not evidence that it's equal to 45 because the sample is probably different than the real mean. Okay, maybe. At least you're all looking this way. So this one must have an equal sign, like equals or, get out of there, Mew. Less than or equal to, greater than or equal to. It's got to have an equal sign, some kind of equal sign. This one can't have this, must be not equal to, less than, greater than. So where would my claim go in this case? Would it be the ho or the high? My claim. Do it.
No hypothesis.
Yes, it would be the ho because my claim has an equal sign. Please don't make that harder. Let me stop here for a second. So in this case, specifically in this case, the ho would be mean equals 45. The high is always going to be the opposite stance. The alternate stance, right? Alternate hypothesis. So what's the alternate stance to mu equals 45? What's the opposite of that? Mu not equal to. Not equal to. Sorry. I yell at you guys all the time. Yeah, I like it. Okay. This would be step one, is what's your claim and what's your hypothesis. Now, obviously, the first time I go through all these steps, it's going to be like, holy shit, this takes forever, but it's because I'm explaining every little piece of it. It's going to go a little quicker when you actually do a problem, right? Please have faith in that. Okay, now, what did I kind of blow right past, and I'm hoping you guys picked up on this. Why was I allowed to even use this to think about probabilities of things? Why was I even allowed to get a z-score and then think about the probabilities related to that z-score? Why was I allowed to do that? Second?
The population was over 30.
The sample size was over 30, so that means that the means would be normally distributed, right? All right, so step one is, what the hell are you talking about? Right? What are you talking about? What's the claim and what are your hypotheses? What are you talking about? Step two is, what are you going to use to talk about it? Now, to be honest, all right, he's a little bit in the weeds here, but I always use a simple z for when I'm calculating my distance. But to be honest, what should I use? And this is going to be a different step, but what am I going to have to use to compare to this? I'm going to have to use since I know S, I've got to use t-score. So the t-score formula doesn't really change from this. Okay? But do you understand, earlier I was saying I want to know what to compare this to. Now, negative 32, I don't have to compare it to shit. Negative 32 is like, I don't care what level of confidence you want. That's way the hell out there. Screw it. But when I get to what about negative 2.01 versus negative 1.98? What about negative 1.67? Is that sometimes okay? It's going to depend on what t-score in this case I use to compare it to. So it's going to be a later step. So the second step is use z or t or nothing. What am I allowed to use to talk about this, right? What am I talking about? What can I use to talk about it? So when I ask you, are you going to use a z or a t-score The answer is never going to be nothing, let me just tell you. In this class, it would be so evil for me to have a problem that has 5 steps where if you just don't realize you don't have to do it, that'd be so evil. So it's never going to be nothing. But theoretically, when would it be nothing? If it doesn't say it's normal and the sample size is not big enough, then I can't do shit. But I'm not going to do that to you. That would be so unbelievably evil. Not quite there. Give me a few more years. Maybe I'll get that evil. Okay. So on this step, you got to tell me if it's normal or not. And then what else do you have to tell me to decide between those two? What tells me the difference between Z or T? When do I use T? Yeah, which standard deviations know? Right? If I know S, I'll use T. If I know sigma, I'll use Z. I like it. Time is okay. We're good. We're good. All right. So what am I talking about? What can I use to talk about it? Now, the heart of a hypothesis test is the third and fourth step. Right? The third step, the fourth step, let me just talk about the fourth step real quick, because that's a step we already can do. The fourth step is just calculating the z-score, like we did earlier. Right? That's old news. And actually, I call it Z-star. So it's the sample z-score. Right? So that's like the z-score. We got the negative 32. That would have been Z-star. Why the hell do we call it Z-star? Well, because I'm weird already. But the reason I do it is because on step 3, I'm going to figure out what far enough away is. So is it negative 2 exactly? Is it negative 2.33 is how far away? Or is it a nuclear reactor and I want it to be negative 1.28 because I want to get off my ass the minute it starts to get a little weird. I'm going to define weird in a much more conservative way then. If it's a nuclear reactor that could blow up, I think I'm going to be a little more careful, right? So that's why the unusual being 2 standard deviations before isn't good enough in general. It depends on the situation. I like it. I like it. So step 3 is we're going to do what's called define the rejection region. So what this means is I'm going to say, for example, for this one, for this specific one, how can I show that something doesn't equal something else? I could show that it's how do you show something's not equal to something else? If I said the cost of this can of soup is $8, and you're like, it's not equal to that. You could show that it's less, or you can show that it's more. So this would be a two-tail test. And now this is what I was talking about earlier when I gave you that t-score chart. If this would have been greater than or less than, that would have been a one-tail test. Hey, t-score chart, you're freaking set up for a one-tail test and two-tail test. Holy shit, nice, right? Maybe. So we are going to have one-tail tests. We are going to have two-tail tests, and that's why this is set up the way it is. I like it. I like it. Okay. So this is going to be where they have to tell me alpha. And this is going to be, the other name for alpha in this case is the level of significance. So I figure out how far away is far away enough, and then I calculate Z-star and C. So this is how far away is far away enough, and then how far away did my sample get, right? So if this is the real mean, then I would expect a sample to show up in here. This is just setting up what's far enough away for me to go, that's evidence that that's not right. So if I got a sample and it's right there, I'm like, well, holy shit, it's right next to the freaking, that's not evidence that it's wrong. It's not evidence that it's right either. You got to be careful. But I would fail to show that this is wrong in this case. But if I got a sample over there, like we just got negative freaking 32. We got way the shit out there. That is evidence that that's wrong. So that's why I say this is the heart of the test. What's far enough away? How far away did we get? And then step 5 is everybody's favorite, the conclusion. All right, so let's look at a specific example, and then we'll call it a day. Yeah, I like that idea. So if you look at the back side of your confidence interval practice sheet, you'll see these 5 steps explained. I love that. So I'm just going to do a little bit more. I don't want to completely fry your brains, just fry it a little bit.
Lightly toast.
Yeah, I can smell it already, so it's going to be. Oh, which one are you going to do? There we go. So look at this example. Let's try to run through this example and then we'll head out. Please don't freak out if you're kind of having trouble understanding. We just started talking about it. Sorry. I'm getting older when you're all excited about sitting down. So read through this real quick. I think I wrote this. I don't know if any of you guys were aware of the world enough back when there was, what was his name? Jim the plumber or whatever it was back with Sarah Palin and all that kind of shit. You guys are probably too young for that. So I was doing a lot of problems where I had Phil the researcher and Bob the builder and whatever else. So Phil the researcher. Now, if you read through this, look at me being all nice and bolding stuff. Don't get used to that. What's the claim that's being made?
Coyotes live longer.
Yeah, so can we write that less Englishy, more mathy? What's that mean? The coyote lives longer in captivity. It means that their average lifespan, mu, what's true about mu?
It's
Greater than, right? Lives longer, so their average lifespan is greater than what? 7.25. I love it. All right, let me stop there. So everybody see where that came from. So the claim should be relatively easy to find. It's just going from English to math. That stuff you always got to be careful about. So which one is that going to be? Is that going to be the ho or the high?
High.
Yeah, why the high? It don't have no equal sign, so it's got to be the high. Look at my great grammar. It don't got no equal sign. And then what's the ho going to be?
55.
What's the opposite of greater than? Less than or equal to. What's the ho always got to have? An equal sign. Now, I think the book has examples that does this both ways. I don't like making the null always equal to, because that's actually sort of lying, to be honest. And it makes things a little bit harder. If my claim was it's at least 6, well, that would be mu greater than or equal to 6. It's not mu equal to freaking 6. So the HO has to be able to be the opposite of H1. End of story. And the HO always has to have the equal sign. Why? Because I want the H1 to be the thing that I can show evidence for. Is this going to be, what do you guys think? Is it going to be a 1 or a 2-tailed test? I'm trying to show that it's greater than, so do I want my sample to show up on either side? No, I want my sample to show up there, if I'm trying to show evidence for this, right? So it's going to be a 1-tailed test up here. Basically, good old greater than points me in the direction of where the tail is. We used to use, for the not equal to, oh, you should be looking the other way. For the not equal to, we used to use this symbol, which we've thankfully stopped, but some of you guys might actually like this symbol better. We used to use the symbol less than greater than. And I always hated that, because math people, we don't like multiple symbols in a row. There's freaking not equal to. But this would make more sense as to why that would be a two-tailed test, because you're pointing in both directions. I'm not equal to, so I must be out there somewhere, right? In this case, it's one direction. Up the group. Nothing. All right. Now in this case, can we use z-scores, t-scores, or nothing?
Z-scores.
Why z-scores? Two things.
You have the standard
Greater than
deviation
30
as
sample.
30.
Sigma is known. The population standard deviation is known. So don't just say, I know a standard deviation. Well, you always got to know a standard deviation. Which one is it? That's what tells you if it's z or t. Secondly, what else? What tells me I can do anything? What kind of distribution do I need?
Normal.
Yeah, so I know that n is,
Greater than 30.
yeah, n is 41, which is bigger than 30. Check, check. So we can use z-scores. It's normal, and I know the population standard deviation, so I can use z-scores. Now here's alpha. Remember, alpha is the area in the tail or tails. So this kicks so much ass. Let's see if I can do this. Alpha is 0.01. I'm using z-scores, right? So alpha is 0.01. I'm using z-scores. So what z-score am I going to use? I can use my t-score chart, right? And I can forgive the people that were not here if they say, shit, man, I want a z, not a t. But the rest of us know the z-scores are at the bottom. So alpha 0.01, one tail. Do you see how beautiful this is? It's a one-tail test, I look up here. If it's a two-tail test, I look down here. Alpha is 0.01, one tail. I use this column, and I go all the way down, 2.326. Oh, 2.3826. Boop. This here, this is my rejection region, is right there. Now, why do I call it the rejection region? Because what would I say about the null? What would I say about the hoe if I get a sample way up here? Would you say that they look wrong or that they look okay? The null hypothesis, if you're having trouble with my choice of words. The null hypothesis. It believes what? It believes the mean is less than or equal to 7.25. So if I find a sample that's here, then something's wrong with what? With what the HO believes, right? I can reject. You're gonna love this. I can reject the hoe. This is why this is called the rejection region, right? This is the rejection region because if I make it in there, I've shown evidence that the null hypothesis is incorrect. I can't prove anything with this. And that's real life. That's just freaking real life. Shit, I don't know. But I've shown evidence, pretty strong evidence, that the null is wrong. So I can reject the null if I get in there. So if Z star, you see now why I call it Z star, because there's a Z right there, and I'm about to calculate another Z. Shit, so I want to differentiate between the two of them. If Z star is bigger than 2.326, we can reject the null hypothesis. Now, if I reject the null, what does that mean about the alternate? If I say this guy looks wrong, that means I'm saying this guy looks right, because they're opposite statements. And the official language we use, if I reject the null, I support the alternate. If I can reject the ho, I can support the high. Okay, I like it. Now, what do we know from our sample for this problem? What do I know from the sample? N is 41. What was sigma?
3.27.
3.27. So what's sigma x bar?
3.27 over rad 41.
That's right. That's like 0.5 something.
Yeah. 0.51.
0.51.
0.7.
0.511. Is that what you guys got? Anybody else doing that? All right, I like it. This step is old. This step is old news. I'm just making a z-score. I'm talking about sample means, and it's a sample, so I have to change the standard deviation. That makes sense. We've done that before. I call it Z-star, but oh well, get over that. Z-star equals what's my x bar? What did I find from my sample? .65. Oh, 8.65. So it's going to be my data minus the mean. We're assuming that the mean is 7.25. Assuming the mean is 7.25, we want to compare against that. 7.25 divided by 0.511, whatever the hell that is, 2.78. By 7.4. So that is how far away our sample got. How far away did it have to get to show evidence that the null is wrong? 2.326. Did we make it far enough away?
Yeah.
Yeah, in fact, you can do it visually. But put a little star on it because it relates to Z star. We made it in there. We can reject the thing that thinks it's down here somewhere. We can reject the null hypothesis. Reject the null. Support the high. Please understand, we are going to do quite a few more examples of this, all right? Just in case you're sitting there going, oh, shit, I'm not going to give you a quiz next time or something. That's insane. I hope to God that just kind of makes sense. If our sample is so far away from the supposed mean, that's evidence that the mean is in the wrong place, that mean is wrong. So we've shown evidence that the mean is more than 7.25. We've shown evidence for that. So how do I write the conclusion? Well, we have found, and this is going to be a lot like the conclusion to a confidence interval in the sense that it's going to sound the same. You just have to reference the physical reality of the problem in there. We have found sufficient evidence. When would I say we have not found evidence is when I don't get in here. But we made it in there. So we found evidence. We found evidence to what? Now, which one's the claim? The ho or the high? Which one was the claim? The high was the claim, right? Right, there's the claim. We put it in the high because it didn't have an equal sign. So that's the language you use. Everybody gets so thrown off by this last step, and people just kind of, randomly choose one and hope that they picked right. But that's insane. Just what's your claim? H1. So what words am I going to use? These words, because that's what goes with H1. We have found sufficient evidence to support the claim, and then you can just copy right from the frickin' problem. The claim that northern Minnesota coyote lives longer in captivity than they do in the wild. I mean, my God. I love the people that don't write that. I'm like, just copy. I'm finally telling you to just copy. The claim that the northern Minnesota coyote lives longer in captivity. Bang. All right. So this sheet, if I were you, I would keep this sheet for a couple reasons. It explains every step and it lists the steps. Those are the steps I want you to use for hypothesis tests. Okay. If you start to do the homework, they break every section into like a different one of these things and focus on it. The actual hypothesis tests will start in like 8.4, 8.5, I think. The ones before that just talk about the different parts. So there won't be a full-blown hypothesis test until later in chapter 8. Okay.
Y'all got like a snapshot of it?
Yeah.
Yes, on this.
Yeah.